Welcome to The Explainer. Today, we're diving deep, literally, into the awesome and frankly terrifying forces at work right under our feet. We're going to explore volcanoes and earthquakes and what happens when the ground we trust to be solid just isn't.
So, think about it for a second. The ground feels permanent, right? Solid. But deep inside the Earth, there's this hidden engine, constantly churning, constantly at work. And this engine, it's powerful enough to move entire continents and reshape our world in a matter of seconds. To really get it, let's start not with the science, but with the people who felt that engine firsthand.
All right, Section 1, when the ground moves. Because before we can even begin to talk about geology, we have to understand the human cost.
This quote, it's from the aftermath of the 2005 Kashmir earthquake. And it just hits you, doesn't it? It's such a stark reminder that behind every number, behind every news report, there's a human story. There's fear, there's loss, and that desperate need for comfort when everything falls apart.
Sometimes the scale of these events is, well, it's almost impossible to wrap your head around. 230,000. That's the estimated death toll from the 2004 Indian Ocean tsunami. And that was triggered by a single massive earthquake under the sea. Just one event that sent waves of pure destruction across 8 different countries.
So that's the what. Now for the why. Section 2, the planet's hidden engine. What in the world is driving these colossal events? Well, the answer lies in one of the biggest, most revolutionary ideas in all of science, plate tectonics. Okay, so this is the core concept right here, plate tectonics. The best way to think about it is that the Earth's crust, the surface we live on, it isn't one solid piece. It's more like a cracked eggshell. It's broken up into these huge, rigid plates that are always, very, very slowly, drifting around. And it's where these plates crash into each other, pull apart, or grind past each other. That's where all the action happens.
And this has been going on for an almost mind-boggling amount of time. If you could rewind 250 million years, you'd find just one giant supercontinent called Pangaea. But as the plates underneath started to move, Pangaea broke apart. Oceans formed, continents drifted, and slowly, over eons, they arranged themselves into the world we recognize today. It's this epic geological journey that's still happening right now under our feet.
So how does it actually work? Well, picture a giant planetary conveyor belt. Deep under the oceans, at places called mid-ocean ridges, hot magma rises up and cools, forming brand new crust. This new crust literally pushes the plates outward. Then, on the other side, where plates collide, the older, heavier crust sinks back down into the mantle to be melted and recycled. This constant cycle, new crust being born, old crust being destroyed, is the engine that drives everything. So, Section 3, Mountains of Fire. All this geological action, it leads us to our first major phenomenon, volcanoes. They are the most spectacular, most dramatic expression of that rising magma we were just talking about. First, a quick but really important clarification. You hear the words magma and lava all the time, right? Here's the simple difference. When the molten rock is still deep underground, full of dissolved gases and under incredible pressure, we call it magma. The second it breaks through the surface and erupts, it loses those gases, and we call it lava. Same basic stuff, just in a different place.
But, and this is a big but, not all lava is created equal. The key difference comes down to one ingredient, silicate. The more silicate in the lava, the thicker and stickier it is. Think of it like honey versus water. Low silicate basaltic lava is runny and flows easily, which is why you get those gentle, flowing eruptions in places like Hawaii. But high silicate rhyolitic lava is thick, almost like toothpaste. It traps gas, building up immense pressure until it blows with unbelievable violence.
And if you want a perfect, terrifying example of that explosive power, you have to look at the 1980 eruption of Mount St. Helens. For 2 whole months, the mountain was literally bulging on one side as magma pushed up from below. Then, on May 18th, an earthquake triggered a massive landslide, which basically uncorked the volcano. The result was a sideways blast and a superheated cloud of ash and gas that just vaporized 232 square miles of forest.
This quote just nails it. It's the perfect analogy.
All that pressure from the thick magma and trapped gas had been building and building, and it had nowhere to go but out. The energy release was just staggering, like hundreds of atomic bombs going off at once.
All right, so from mountains of fire, let's move to the other major consequence of plate tectonics. Section 4, the shaking ground. We're talking about the terrifying phenomenon of an earthquake.
Earthquakes don't just happen randomly. They happen along faults, which are basically giant fractures in the Earth's crust. Think of them as the seams where the tectonic plates are grinding against each other. For years, sometimes centuries, they can get stuck, locked together by friction, all while building up an incredible amount of stress and strain.
When that strain finally becomes too much, the rocks suddenly slip. Now, if the crust is being pulled apart, you get what's called a normal fault, where one block of rock slips down. But if the crust is being smashed together, you get a reverse fault where one block is actually pushed up and over the other. Either way, that sudden movement releases energy in the form of seismic waves, and that's what we feel as an earthquake.
And these faults can be absolutely enormous. 800 miles. That is the jaw-dropping length of the infamous San Andreas fault system that slices right through California. It's the active, constantly shifting boundary line between the Pacific Plate and the North American Plate. Okay, Section 5, Living on the Edge. Which brings us to the really critical question. With all this incredible power rumbling just beneath us, how do we coexist with it? How do we manage to live on the edge of these incredibly active zones?
History gives us a pretty sobering look at the potential for destruction. Look at San Francisco in 1906. The earthquake was huge, but it was the fires that broke out afterward that destroyed most of the city. Or Kobe, Japan in 1995. That quake caused over $100 billion in damage. The threat is global, and it's always there.
And this danger, it's as old as civilization itself. In the year 79, Mount Vesuvius erupted and completely buried the Roman city of Pompeii under a thick blanket of ash. And what's just incredible, archaeologists discovered these empty spaces, these voids in the hardened ash. By carefully pouring plaster into them, they created these hauntingly detailed casts of the victims, preserving their final, tragic moments in time.
But here's the thing, we're not helpless. For people who live in these at-risk zones, preparation is absolutely everything. That means simple things like securing heavy furniture to the walls. It means knowing exactly how to shut off your gas, water, and electricity. Having a disaster kit ready to go, and knowing what to do in the moment. If there's an ashfall, stay indoors. If there's an earthquake, get under a sturdy table or into a doorframe.
Which brings us to a final, really profound question. After everything we've seen, after all of our science and all of our preparations, can we ever truly control these immense forces? Or is our relationship with our own planet less about control and more about respect and coexistence?
And in the end, maybe this is the real answer. No one can control the forces of nature, and the only thing left to do is to simply live. For the millions of people living on our planet's most active fault lines and next to its sleeping giants, this isn't a philosophy, it's a daily reality. The goal isn't to conquer nature, but to understand it, to respect its power. To live not in constant fear, but with a deep awareness of the incredible, dynamic, and powerful world we are lucky to call home.